Hi, I'm Bob Tabor with LearnVisualStudio.net. So in this lesson, we'll get back into the Visual Basic programming language and talk about declaring and using variables. You've probably seen a simple algebra problem like this. 5 plus x equals 7. Solve for the value of x. You can figure out it's 2 pretty easily, right? So without a whole lot of thought, but using that same thought process, take a look at these lines of code. X equals 7. Y equals x plus 3, console.writeLine the value of y. What would you expect to be printed to the console window? Obviously, the value 10. So you just read Visual Basic without me trying to explain it to you. It's just common sense, right? Well, for the most part, yes, but honestly, there's a little bit more to it than that. First of all, within the Visual Basic parlance, the name for x and y in this context is a variable. And a variable is simply a bucket in your computer's memory that holds a value. You can put stuff in the bucket and you can read stuff out of the bucket, or rather in memory and out of memory. In this case, these buckets are just holding numeric values, but we can create different kinds of buckets that will be just the right size for date data, for strings of information, for times, and for really big numbers, for values after the decimal point, and so on. But in the case of our little code snippet, we would expect both x and y to hold numeric values. Now, we know that, but somehow we have to use Visual Basic to express that intent so that when it gets compiled into an executable and run by the .NET Framework runtime, it will be able to create two buckets, two variables in memory, holding values that we need to put in there and read out of. Okay, so how do we do that? Well, let's start by creating a new project and then writing some code to illustrate some of these ideas. So we'll go to File, New Project. In the New Project dialog, we want to make sure that Visual Basic is selected on the left, that Console application is selected in the middle, and here I'm going to double-click the full name, Console Application 1, which is there by default, and change that to Variables, and then click the OK button. Alright, and then, just like we did previously, I'm going to make some space for myself between submain and end sub, and I'm going to start typing the following lines of code. So if you're going to follow along, please pause the video as I type or rewind so that you can type this in yourself. But whatever you do, make sure that you're typing the code in with your own hands. This is the best way to learn. Alright, so let's begin. Alright, so let's take a moment to break down the code that we just wrote. First of all, in lines 5 and 6 in my code window, this is where we declare our variables. To borrow from the earlier explanation that I used in this lesson, we're asking the .NET runtime to allocate a space in the computer's memory that's sufficient to hold numeric values. We're asking it to create two buckets that'll hold values that we want to drop into them. So after we've created the buckets, or rather the variables, we can begin to assign values into those variables. And most importantly, we want to assign integer values into those variables. Now, an integer is a mathematical term that refers to a number that has no fractions or decimal values. The .NET Framework and Visual Basic repurposed that idea to say that it can contain values in a computer's memory that are between a negative 2,147,000,000 and some change to a positive 2,147,000,000 and some change. So if you need to store an even larger number than that, then you're going to need to use a different data type. Or to continue our bucket analogy, you're going to need a bigger bucket to hold more information. So after we've declared the variables, we can now access the variables, assigning values to the variable or reading values out of the variable. And we did both in the following lines of code. So first of all, we assign the value of 7 into the variable called x. Then we read that value out and add 3 to it and assign that to the value of y. This equal sign is actually an assignment operator. So in English, that line of code is basically saying set the integer called x to the value of 7, for example. So then notice that we're then passing the variable called y, or retrieving its value from memory, we're going to pass that to our WriteLine method that we used previously, trusting that WriteLine will know what to do with an integer. Now it just so happens, and we looked at this previously, that there are 18 versions of WriteLine, and we'll talk about versions of methods or versions of procedures a little bit later. One of these will be able to work with an integer. You can see it's version number 7, okay? And that may not mean a whole lot to you just now. Don't worry about it. We'll come back to that concept a little bit later. So now let's go ahead and see if it actually works by start debugging. And you can see that it does print the value 10 to the console window, which is perfect. All right? So this is a good time to save our work. I'm going to go ahead and click on the Save All button on the toolbar. Again, that will pop open the Save Project dialog. I'm going to accept all the default settings and click the Save button. Great. So since we're going to create a number of small examples in this video, what we need to do is comment out the work that we just did. If you recall from the previous video, we can accomplish this in a couple of different ways, but the way I'm going to do it for right now is just use my mouse, highlight all the lines of code except for this last one. I'm going to click the Comment Out the Selected Lines button on the toolbar. And then I'm going to make some more space for myself. All right, let's move on to a second code example. So go ahead and follow along with me as I type. Don't forget that you can pause and rewind. Okay, so let's go ahead and break these lines of code apart. First of all, instead of an integer, this time I'm declaring a variable called as type string. And a string can hold textual information, alphanumeric characters. Also notice that I can name my variables anything I want within certain limits. So as a convention, I used a convention called camel casing, which says the first character should be lowercase, and then each subsequent word should start with a capitalized letter. And that's a common convention to use for locally scoped variables. And we'll talk about scope in another video. But for now, just go ahead and follow this basic convention whenever you're naming your own variables. For now, what we're going to do is just use integers and strings in our applications, but there's probably a dozen other data types that you'll eventually want to know, and we're going to add those in subsequent lessons. So now we're going to run the application, and just to make sure that we get the result that we expect, and indeed we see the word Bob printed to screen. And at this point, our code example is just a glorified version of the hello world that we created in lesson number 2. The only difference is that we used a variable to hold the literal string. In this case, the literal string is Bob, not hello world. And then we use that variable in the console.WriteLine procedure or method. A couple of other things that we need to note about Visual Basic itself. Let me create a second variable. And this time, I'm going to name it exactly the same thing, my first name, but I'm going to use lowercase letters. Now when I do that, notice that the IDE places a blue squiggly line beneath my first name. If I hover my mouse cursor over it, you can see that it says local variable my first name is already declared in the current block. So what I understand that to mean is that Visual Basic is not case sensitive. In other words, these two are exactly the same regardless of the capitalization. All right. Furthermore, if I attempt to type out my first name in all lowercase and I hit the space bar, it will capitalize the word I just typed in to match its declaration earlier in code. So the IDE in Visual Basic enforces those sorts of conveniences for you. It doesn't really matter because once it all gets compiled, it doesn't look at the capitalization. However, for our visual presentation to other developers and to ourselves, it's sometimes helpful to see things the way that they were originally declared, capitalization and all. All right? All right, so let me just go ahead and get rid of that. So there's one other thing that I want to point out, and let me just highlight that line of code, Control X and Control V to paste it back in. All right, so we have two lines of code. The first line of code dimensions a variable, declares a variable, and then the next line of code assigns an initial value to that variable. But what if we were to take both of those steps in a single line of code? So let's do this. And so not only is this perfectly legal within Visual Basic, it's oftentimes encouraged. Many times experienced developers like to write less code, and they like to initialize their values as early as possible. So they're always looking for convenient ways not only to reduce the amount of code, but reduce the ambiguity of what is stored inside of a variable. And so this method, this technique, accomplishes both of those tasks. So let's take one other step that we can do now in some later versions, newer versions of Visual Basic. So we have dispensed with the as string altogether. Let's go ahead and run the application. Would this even work? Well, it would if I spelled this correctly. There we go. Let's run it now. There we go, and it still works. If we were to hover our mouse cursor over the my first name variable, notice that it does print out the full declaration as dim my first name as string. So what's going on here? So several years ago, after Visual Basic was created, a few innovations were added to the programming language to reduce the amount of code that you had to type, and also to allow for a more complex coding style, or to at least to make it easier to work with some complex types, which we'll talk about much later in this series of lessons. But starting in Visual Basic 2008, I could shorten it to this, and the idea is that the Visual Basic compiler is smart enough to see what you're initializing the new variable to contain, so why not just let it figure it out instead of us trying to figure it out. So it's always important to know that in this case the variable my first name is of data type string. As we can see here, it clearly sees it as a string. It's not an unknown data type. And so once we declare the variable using this style or technique, it can never hold any other type of data like an integer or a date time or anything else. So let's just, for fun, see what happens if we were to try to shorten it just to this, my first name. And we leave off the as. And if I hover my mouse cursor over it now, it's no longer a string, but rather we can see that it understands my first name to be an object, which is the most generic type of data within Visual Basic and within the .NET framework. In other words, it can hold any other data type, any kind of information, anything you want to throw at it, which might seem like a pretty cool idea. However, this is a horrible idea because it gets around the restraints of using a strongly typed programming language. We'll talk about strongly typed a little bit later, but you might think, hey, I can store anything I want in there. It has to be great. However, I assure you what seems to be freedom is actually a noose because it'll lead to errors that are difficult to track down. So trust me, stick with defining your variables with data types like as string, as integer, whatever the case might be, or setting an initial value, and stay as far away from object as possible for now. That's my warning to you, and I can't really go into any more explanation at this point, but trust me, we'll get to that in a little while. Let's do this. Let's comment out this as well and move on to yet another example. All right, so here we go. Okay, let's save what we've done so far and then attempt to run the application. And when we do, a couple of things just flashed right before you right there. Let's go back to the console window on the taskbar. And you can see that 7Bob is printed to screen. So how did it get to that? Well, it took the value of 7, or rather of x, which is a value 7, and concatenated it to the value of y, which is Bob. Now look, I'm in what's called a debug mode now, and I'm hovering over my variables, and notice the little helper windows that I get that show me the values inside of the variables. Pretty cool, huh? So it was able to implicitly convert 7 to a string so that it could concatenate it to the word Bob and print that out successfully to the console window. However, in this second case, we get this conversion from string Bob to type double is not valid. Focus on this beginning part, conversion from type string to double or a numeric value is not valid. Okay, let's shut that down. At issue here is that we are relying on an implicit data type conversion in both cases. In this first case, we have a widening conversion. Because a string can hold so much more information than an integer, we're able to successfully give our string the value of 7, and it can treat it like a string of literal alphanumeric characters. However, in this second example, we're trying to narrow or fit a big square peg into a little round hole. We're trying to put the word Bob into something that we intend to be an integer, and it doesn't know what to do with that scenario. So it throws its hands up, and it has issued a runtime exception or an error at runtime as we're running our application. So there are a couple of things we can do to remedy it. We're not going to fully remedy the situation until we change this value of y to be something other than Bob. But we can start, and let's just click the stop debugging button in the toolbar to just end the program without finishing it. We can begin this process of improving our code by converting this value of y first to an integer and then attempting to add it. So we're going to take an explicit conversion step. So CINT, that's short for convert to integer, and then whatever we pass in. In this case, we're going to pass a string. Now we can run the application a second time. We're still going to get an error. However, what we're attempting to do here, a conversion from string Bob to integer to type integer, is not valid. That's a better error because we have taken control of the conversion process, and by specifying that we need to perform this conversion. So the only way this really gets resolved, as I said before, is to change the value of Bob to the value of 5. And so now when we run the application, we can see that we successfully get a second number, 12, which is indeed 7 plus 5, right? Visual Basic has a number of these explicit type conversion methods, or procedures rather, that know how to take a value of one type and convert it into another type. Based on all this, you might think, well, why are we relying on that then in this step? And how did that work? Well, we already talked about how it worked, but how can we take more control and not just allow this implicit type conversion to happen? Well, the same is true in reverse. What we can do is go a CSTR for convert to string, then the value of, the value of X. Wrap that around the wrong thing here. CSTR, there we go. And just to be clear, and we'll talk about operators in just a moment, but the ampersand in Visual Basic is the string concatenation character, as opposed to the mathematical addition operator. All right. So we want to append these two strings together. We convert X from being an integer into a string, and then we append it to the value of Y in order to print out 7 and 5 to get next to each other. Okay? There's one other way, and I want to just point this out as we get started here. And this might be a little bit mind-bending at first. I'm going to call a procedure called toString. So take whatever your value is and convert it to a string and then append it to the value of y. So it might shock you to see that even these simple integer values have a member accessor to get to some additional methods. And the reason why this happens is because every data type in the .NET framework and in Visual Basic all derive from a parent type called object. There's the object again, right? And so object has some very basic features that all child types that inherit from it receive. It's like an inheritance. And so the integers inherit that just like strings and other types of objects. So at any rate, we'll come back to that notion. Don't worry about it too much just at this moment. It's just another way to do a string conversion or from a different type. All right, so the key idea in this lesson is how to declare, initialize, and work with variables and data types. In the .NET framework, even simple data types like the integer have some powerful helper features to convert one data type into another data type when needed. Again, we'll come back to that a little bit later. So hopefully this was enlightening. It's definitely a building block in the right direction. You're doing great. Hang in there. We'll see you in the next video. Thank you.